when you may get, say, a single input, then you just wanna switch among those. Okay, we'll be starting with the for loops or the for statements. So this is the structure of a for statement. You have the for, then your code to be executed is written inside the curly braces. If you can notice, if you miss one of these curly braces, then it's the beginning of the end. Like you'll get errors and they will bug you out. So you have statement 1, 2, and 3. So statement 1 is executed like one time before the execution of the code.
So,
hello.
I don't know if you can see, but there's someone who has their hand up.
No, I can't see things I'm presenting.
Oh, yeah. Someone has their hand up.
Whoever has their hand up, please ask away.
I'm sorry, it was a mistake.
Oh, okay.
Oh, okay.
Okay, so you have statement 1, 2, and 3. So statement 1 is executed before the execution of the code. So what this means is before the code inside the curly braces is executed, we first execute statement 1 because it's the initialization statement. It's often referred to that. Statement 2 defines the condition for executing the code block. So statement 2 at times is called the stopping criteria, or what must you meet for the for loop or for the for statement to stop. Then statement 3 is executed every time after the block code has run. So statement 3 is only executed after the code that is executed inside the curly braces is complete. So once it hits this curly brace, the last one, the closing one, then it comes back and executes statement 3. So when it gets inside the for loop, before it starts with statement 1, then executes the code, then goes to statement 3. Then before starting again, it evaluates then statement 2. If it still holds, then continues. This is an example of what I was talking about. So you have your for. This is the statement 1, sometimes called the initialization criteria. So here we are initializing I to 0, meaning we are saying int I is equal to 0 when the for loop starts or the for statement starts. Here we are giving it the stopping condition, which is the statement 2. So we are telling it that I should be strictly greater than 5. So you see it's not less or equals to or something like that. So we are saying it should be strictly less than 5. So here we are giving it the update criteria. When you see I++, we are saying it should increment by 1 at the end of each execution. So this is the code inside the curly braces. As I said, it will the for statement will start initialize this, then get inside. Upon executing this the closing brace, it will come back, evaluate this statement if it still holds. Then if after updating here, it evaluates here if it still holds, then get inside, then do the same thing up until this statement no longer holds. It will then be finished. So this is another example. So here you have, if you still remember from our previous lecture, you have an array of numbers. So first we get the numbers or the length of the array. Then here the stopping criteria or statement 2 will be the length of the entire array. And we are still incrementing by 1 at each time, and we're initializing our I by 0. So before getting in, you will evaluate this statement. Is I less than the length of the array? No, because I is 0 and the length of the array is not 0. Then it executes whatever is in the body of the for statement. Then upon hitting this, it comes back, increments, then checks if this statement 2 still holds. If it does, it then continues and does so up until the statement fails. So we also have for each statement. So this one is sometimes perceived as a shorter variation of the for loop, because the for loop has 3 statements, whereas this one sort of traverses or goes through the array without sort of indexing it and having to update it at each loop. So the syntax for each statement goes like this. You have your for, then give it your type, such as int, then the variable name, you have your colon, then you give it the array name. For instance, previously we were using like array numbers, then here array name, you'd be using that one. So here, that's where you include the code that you want to execute. An example is here below. So we have an array of cars. Obviously, all of them are string, as you see the type. You have Volvo, BMW, Ford, and Mustang. When you start, we'll say string I, because you need to give it the type, then the variable name. So the variable name here will be I. Then you're saying we'll be going through the array of cars. So the code that will be executed is this one, system.output.println at I. So at each instance, it will start at 0, obviously. As I said last week, in Java, we count starting from 0. So it will print Volvo, BMW, Ford, and Mazda. Now we go to if statements. So Java does support the usual logic from mathematics, less than something like this. So intuitively, you read this as A less than B. So with Java, you'd have to say if A is less than B, then execute something, or then do something. Less than or equals to, greater than, greater or equals to, equal to, and this is how we write equals to, not only one equal sign, because an equal sign is you assigning whatever is on the right to the left. So if you say variable A is equals to B, then you're saying you're saying whatever is stored in B is now going to be stored in A. So be careful of that. So this is how we write our not equals to. It's exclamation mark equals to. So you say A is not equals to B. So this is one of the logic that we use when we're trying to evaluate or execute our if statements. This is one example. So this is the exact syntax we will be following. So you have your if, your condition, then the block of code that you want to execute if this condition is true. Because if the condition is false, it will then skip everything, then execute the code below. But if there's no code below, then it will just leave it at that. So let's take this for an example. You have int number is equal to 21, int number 2 is equal to 3. So here, again, the syntax says if num1, which is 21, is less than num2. Okay, this is an error. This is a mistake I meant to say. It's not supposed to be here, because if you execute this block of code, it will actually give you an error. So if num1 is less than num2, then int highest is equal to num2. Intuitively, you have to look at this before you even give it to your compiler to do it for you. So num1 is 21. Is 21 less than 3? No, it's not. So this block of code inside wouldn't be executed. It will just execute this. Then after it fails, it will execute everything that follows. If there's nothing, then it will just tell you that it returned a certain output, or and like nothing was returned. So if it happens that say you flip this, if num1 is greater than num2, which would be true here, then int highest, meaning the variable highest, would take the number that's stored in num2. So here now we are combining an if with the else, right? Because you know that even if you're doing something, even in real life, you're bound to have what if it doesn't happen, or what's the alternative to this condition. So here again we have num1 is equals to 21, we have num2 is equals to 3. If num1 is less than num2, again as I said, this is a mistake. So if num1 is less than num2, then int highest is equals to num2. Then else says if this condition fails, you skip whatever is inside here, you don't execute it. Then else you execute whatever is here. So it would skip this entire block of code, whatever is in line 4, and execute what is in line 6. And this is an example of the else if statement. So with else if, let's go back a bit. With the else, it just says if this is true, execute that. If it's true, you don't execute this, like line 6. But if it executes that and it finds this is false, it sort of won't ask any questions and will check the else, then just go straight to 6. It becomes different when we have the else if, because it will again start here, you initialize your variables. It says if num1 is less than num2, then execute this block of code. As we know that num1 is like greater than this, so it won't execute that. Then it goes here, else if. You see there's else if, then there's else. You should be careful of this. So it says execute this condition. If it fails, try the other one, try the alternative. So it says else if num1 is greater than num2, which is true in this particular instance, then it will execute whatever is in line 5, which is this one. Then after this becoming true, it will not execute anything that is inside here. But then a case that you'd cover here is when the numbers are equal. So you then cover that logic. But then if it fails 1 and it fails 2, when it gets to line 6, it won't even think, sort of, it wouldn't, because there's no logic here. We'll just say else, just execute whatever is in line 7. And we have the while loops. Sorry about that. The while loops are similar, another logic of looping logic. They are similar to for loops, just with them they don't have the criterion or the statements as you saw with the for loop and the for each loop. They have a single condition, similar to what you'd find in the in statement 2 when using a for statement or a for loop. So you have the while, literally, that's why it's called the while loop. You have the condition, and inside the curly braces again. Don't ever forget these guys, please note it down. Inside the curly braces, you have the code to be executed. This is an example of how you'd write your while loop. So int I is equals to 0. Then you say while int I is less than 5, then do this, meaning print this, update my I, then go back. So it will say, like it will execute what's in line 3 and line 4 up until this condition fails. So the first time you see, we start by initializing I is equal to 0. The first time it checks this, while I is less than 5, true. It will execute this up until I hits 4, because then you'll execute that, print 4, then increment to 5, then come back, then it will say I less than 5, but it will now be 5 less than 5, which is false. Then you don't execute anymore. It skips everything, then executes anything that is below the while loop. You have the do while loop. So the do while loop is when you want something to execute at least once. An example would be, say you want to add numbers before doing anything, like you want to perform, say, a sequence of operations on some numbers. If you want it to execute at least once, the do while loop is for you, because you'd say do, then the code to be executed, let's say addition of arithmetic numbers, like say 1 plus 1, then you check the condition afterwards that say while the answer is less than 2, then don't continue or something like that. Because if now you've added those two numbers, say 1 plus 1 is equal to 2, and it says while maybe I is less than 2, do not execute, it will not continue. So you've executed your code at least once. So you should use this if you wanted to execute at least once. So an example would be below. So int I is equal to 0, then do system print line. Then you say while I is less than 5, do this. So you will first print out 0. If you remember the first one, it like the while loop, it first checks is like while I is equal to 5, then prints. But with this one, it will first print out 0, then increment. So by the time it checks while I is less than 5, it would have printed out 0, incremented I to 1. So by the time it hits the statement, I is already 1. Okay, guys, before I move to the switch case statement, does anyone have any questions? Okay, I'll assume everyone is okay. So this is the switch case statement. So the syntax is literally like this one. So first you have your expression, then again kill braces, guys. Don't forget, you have case value 1, case value 2, case value 3 up to case value n, right? Then you have the default statement. So default statement is, okay, here can be perceived as how you'd see the else when you're using ifs. So with the default statement, we are saying if anything else here doesn't meet what we are looking for, or the requirements that we're looking for, then just the default statement will be true, or is what will be taken. So case value 1, if it's true, you'll execute whatever is statement 1, then you break. Don't forget these break statements, because after executing it, it must break out. Because if case value 1 is true, it executes the statement here in line 4, breaks, then goes towards what's beyond line 14. So this would be an example of a switch case statement. So we have int I is equals to 9, then you say switch I. This is the expression we are trying to switch. So to say case 0, system to print down to print line I is 0. So when you say case 0, it uses this expression to evaluate whatever you're saying. So case 1, same thing, system like we will print out I is 1, you break afterwards. Case 2, I is 2, you break afterwards. Then the default statement, you'd say probably I is greater than 2. So in this particular instance, since our I is 9, it would come here, give this expression, then goes to case 0, fails, goes to case 1, it fails, goes to case 2, it fails. Then it has no choice but to execute the default statement. Then it prints out I is greater than 2, which would be true in this particular instance. So with the nested statements, I think we'd be covering them sometime later. So yeah, because you can have a switch case inside of a switch case inside of another one, or you can have a nested form of what's this? You can have a nested form of if statements, or you can have a combination of if statements, switch case statements. You can have a combination of for loops, ifs, and switch cases. So those ones would be covered later. I'll probably try covering them first thing next week before we start with the other content, so you see the different variety of the things we might do. And just to end off with a joke, if you've started coding, you'll probably understand this one. So there are two types of people. Personally, I'm the one on the left. I hate everyone on the right. I'm kidding. So yeah, guys, that was our lecture for today, and I'll be taking any questions from now. Hello, questions?
Okay, seems like there aren't any more questions. I guess we'll just end it here then. Thank you so much to everyone for joining in.
Okay, no problem. If you have any questions, guys, just jot them down. Then you can ask them before we start next week, or you can even ask them on the WhatsApp group.